Greetings. I'm going to go through the work of David Mark Keirsey. So he's the son of the psychologist, and the profile was mostly based on him. So, and Wojtek has said that, David Mark Keirsey is INTP as heck, and I've cleaned it up. So here we go. David Mark Keirsey, son of David West Keirsey, is indeed a thinker with deep theories relating to physics, information theory, and temperament. Again, it's the son. His writings, including those on his blog and websites such as edgeoforder.org, revolve around ideas such as a finite informational framework of reality based on 27 non-abelian finite simple sporadic groups as fundamental information atoms underlying physical phenomena. Full disclosure, I don't know what he's talking about. Right. Critiques, but there are a lot of smart people who follow this channel. So you might be able to, provide feedback yourself and spread it around. Critiques of conventional physics reliance on notions of infinity, continuity, and smooth space-time, suggesting these lead to conceptual cul-de-sacs. His Formatics framework, which integrates multiple knowledge domains, that's very INTP, information theory, physics, mathematical rigor, and an evolutionary-involutionary model. Efforts to replace or extend current quantum mechanics and cosmology with discrete, finite, information-theoretic foundations tied to group theory and mathematical structures like the Leech lattice and monster group. An emphasis on Gestalt science, again bringing it all together in a whole view. An Uber theory, positing that a full understanding of physical reality requires unified physical models, rigorous finite mathematics, informational frameworks, and flexible evolutionary perspectives. At the end, I'll show you some questions from a mathematical point of view for those with the relevant know-how. So here we go. Keirsey's work shares traits with very abstract, integrative, and mathematically sophisticated approaches to physics and information science, addressing some foundational problems in contemporary physics from a novel angle by incorporating group theory and finiteness explicitly as core principles. Objective assessment. So this is from Perplexity. Innovative and ambitious. His attempt to use finite group theory and information theoretic ideas to underpin physical laws is novel, tackling long-standing conceptual issues in physics like quantum gravity and unification from a different perspective. Highly theoretical and abstract. The theories are mathematically complex and built on advanced algebraic structures. They require a high level of abstraction and expertise in both physics and mathematics to fully grasp, which limits accessibility. Complementary to mainstream physics, Keirsey is critical of traditional physics models where they struggle with infinity and continuity assumptions, but does not reject empirical science, rather proposing a new conceptual foundation. INTP profile reflection. His approach fits the INTP cognitive profile archetype, characterized by deep theoretical thinking, pattern seeking, and an interest in foundational principles beyond surface phenomena. It's almost as if you can't get more INTP than him. Lack of mainstream acceptance. As with many advanced theoretical frameworks outside orthodox physics, his ideas are not mainstream and await wider validation. That's what we're trying to spread it, get it out there. Wider validation, or at least I am, or adoption through peer-reviewed scientific scrutiny. So, in summary, David Mark Keirsey is proposing a sophisticated, mathematically grounded framework blending physics and information theory with deep theoretical insight. His theories challenge and seek to extend existing paradigms by emphasizing finiteness, information structure, and evolutionary logic, fitting the profile of a highly abstract integrative thinker often associated with INTP personality traits to the extreme. This is a rich and complex field where full assessment demands deep expertise in advanced physics and mathematics, but prima facie, his contributions represent a unique and ambitious alternative to classical models. Now, I'm going to show a PDF I exported. I need to switch my share screen. Window. That's it. Right. Bit width. So if we get down into the nitty gritty, so hopefully there's someone out there with the, or more with the mathematical competence. So I'll just show this rather than read it through. But okay, I'll read it through anyway. Certainly, here is a more mathematically rigorous elaboration intended specifically for David Mark Keirsey that dives deeper into the algebraic and representational framework of sporadic groups as fundamental information entities. Now, towards the end, he has questions for him. Advanced mathematical elaboration on sporadic groups as informational primitives. Sporadic groups as finite, simple symmetry objects. Now, I'm going to make that bigger. No, I won't get greedy. Each sporadic group, $G$, is a finite non-abelian simple group characterized by unique algebraic properties, distinguishing it from the infinite families of Lie type and cyclic groups. The finite simplicity of $G$ means it has no non-trivial normal subgroups, establishing irreducible atomic symmetry units in discrete mathematics. Now then, just a little sidebar. For all those socionics people that believe that thinking is external, do you believe that all of the meaning is getting across from these signifiers? Don't you think the whole point is that it's hard for David Mark Keirsey to get what is in his head, to get across his thoughts? Right, and that there is a big subjective factor. Mathematically, $G$ acts as a finite symmetry group on a vector space or combinatorial structure with transformations reflecting symmetry operations. Now, I can tell you, I don't know what it means. Now, again, the people that believe in socionics that thinking is external, do you instantly know what this means? I don't think so. Minimal faithful representations and information encoding. Let $, you can see, be a faithful, irreducible representation of over the complex field, where you can see that this means, okay, we're getting very technical now, but okay, the vector space $V$ serves as the carrier of informational states analogous to quantum states in Hilbert space. Again, Hilbert space, there's a whole thing that points to, a knowledge base. But if someone who doesn't know about it, they're just hearing Hilbert and space. How does the information go across? It doesn't, it's just a signifier. This is why the subject's called semantics. A subject called semantics. The dimension determines the information capacity, the number of orthonormal basis states. Orthonormal. Right. States analogous to qubits. I don't know what that is. This establishes an isomorphism between group elements in unitary operators acting on the information space. Right? Okay. Well, just hang on a moment. View mode. No. View. I want the continuous. Right. There we go. Tensor product structure and compositional algebra. The combination of two informational atoms corresponding to groups G1 and can be modeled algebraically. So people out there with the requisite STEM knowledge, do you get this? I don't. The tensor product structure allows representation of composite informational systems encoding the interaction and entanglement of the fundamental sporadic group units analogous to multi-qubit quantum systems. Right. Fusion rules and representation category. The category of representation finite groups admits a fusion algebra structure describing how irreducible representations combine under tensor product decomposition. The fusion coefficients specify the interaction and composition rules for informational units, providing an algebraic skeleton for how discrete physical states can evolve and interact. Moonshine and modular forms as physical data. The monster group characterizes deep moonshine phenomena connecting its graded character with modular functions. The coefficients correspond to multiplicities of irreducible linking group representation theory to modular invariants in 2D conformal field theory and string theory. This suggests an avenue to encode partition functions, scattering amplitudes, or state counts in the physical theory via modular objects associated to sporadic group representations. Discrete spacetime and algebraic dynamics. Assuming a finite informational framework, spacetime is modeled as an algebraic structure derived from combinations of sporadic groups via incidence algebras over group posits or cohomological invariants representing topological constraints. Dynamics will be governed by group cohomologies with coefficients in modules encoding allowed transitions and invariants under symmetry operations analogous to gauge fields in continuous theories. Now, for those in the know, these are the questions for him from Perplexity. Can you explicitly construct and classify the minimal faithful complex representations for each sporadic group and interpret the basis vectors as fundamental informational states? How does the fusion coefficients relate to physical interaction amplitudes or transition probabilities in your Formatics framework? In what manner do moonshine modular forms inform the partition functions or observable spectra within your theoretical construct? Can you formalize a function or can you formalize a functor from the category of finite sporadic groups to a quantum information category in your framework, uniting group symmetries and quantum states? How would dynamical laws encoding evolution operate as algebraic morphisms or automorphisms within finite group framework? Have you formulated explicit algebraic or topological invariants derived from sporadic groups that correspond to conserved physical quantities or quantum numbers? This structured, mathematically precise perspective aims to assist in extending, formalizing, and communicating the theory's core insights rigorously. If desired, I can draft. Right, so anyone who understands this, a bit of this, or knows someone, please pass it on and to help to get more feedback to David Mark Keirsey. And so there's more on his website, edgeoforder.org, not com. I keep forgetting that. It's .org.